Welcome to our specialized series on industrial artificial intelligence. Today we are exploring a fascinating concept called K Nearest Neighbors, or KNN for short. Have you ever wondered how streaming services recommend your next binge watch, how your email filters out annoying spam, or even how computers learn to read handwriting? KNN is a fantastic place to start. And the best part? It requires exactly zero complex math to understand. Let's dive in. Imagine you want an AI to categorize movies into two distinct genres, action and comedy. You decide to map out the movies you already know on a giant graph. You base this graph on two simple features. On the bottom axis, we track how many explosions a movie has. On the side axis, we track how many jokes it has. So, you plot your data. A cluster of red dots appears on the bottom right. These are your action movies, packed with explosions but short on laughs. A cluster of blue dots appears on the top left. These are your comedies, full of jokes but light on the pyrotechnics. Now, a brand new movie hits the theaters. We don't know its genre yet, but we have its stats. It features exactly 50 explosions and 10 jokes. We drop a mysterious gray question mark onto our graph right at that spot. If I asked you to guess what genre this mystery movie is just by looking at the graph, what would you say? You'd probably shout, action. Why? Because it's completely surrounded by action movies. Congratulations, you just executed the K Nearest Neighbors algorithm in your own brain. But let's break down the name. What exactly does the K in KNN stand for? K is simply a placeholder for a number. It represents the exact number of closest neighbors the algorithm looks at before making its final decision. Let's play with this K number to see how it changes things. If we set K to 1, the AI puts on blinders and only looks at the single closest dot on the graph. It taps that neighbor on the shoulder and asks, "What are you?" If that one neighbor happens to be a comedy, our new movie is labeled a comedy. But what if that single neighbor was just a weird, experimental indie film that doesn't fit the mold? Trusting just one neighbor can be risky. To be safe, we usually make K a slightly larger odd number like 3, 5, or 7. Why an odd number? To avoid a tie vote. If we set K to 5, the AI draws a circle around the 5 closest movies and takes a democratic vote. If 3 are action and 2 are comedy, action wins. It is literally just majority rules. But wait, what happens if we make K too big? Imagine we set K to 100, and we only have 120 movies on our whole graph. The circle becomes so massive that it includes almost everything. At that point, the AI stops looking at the nearest neighbors and just picks whatever genre is the most popular overall. Finding the perfect K is all about finding the sweet spot between trusting the closest guy and trusting the whole crowd. Now, you might be wondering, how does a computer actually know which dots are the closest? It doesn't have eyes. Instead, it does exactly what you would do in geometry class. It takes out a virtual ruler and measures the straight line distance between the points. In mathematics, this is called Euclidean distance. The algorithm patiently calculates the distance from our mystery movie to every single other point on the entire map. It then ranks those distances from shortest to longest and picks the top K closest ones to form the voting committee. So how do we choose the best value for K? One common approach is to test different values of K and measure how accurate the model becomes. On this graph, the horizontal axis represents different values of K, while the vertical axis shows the model's accuracy. As we increase K from 1, the accuracy initially improves. This happens because the model starts considering more neighbors, making its predictions more stable and less sensitive to noise. But if we keep increasing K too much, the accuracy begins to drop. At that point, the algorithm starts considering too many distant neighbors and the decision becomes too generalized. The goal is to find the sweet spot, the value of K where the accuracy reaches its peak. In this example, that optimal point occurs around K equals 5. This is what we call the best K value. KNN is incredibly popular in the real world because it is elegant, it's intuitive, and it features something called lazy learning. Unlike heavy AI models that need to train for days in massive server farms, KNN doesn't train at all. You just drop the data onto the map and it sits there waiting lazily until you ask it a question. But there is a catch. Because KNN calculates the distance to every single piece of data to find the closest neighbors, it can get really slow if you have millions or billions of data points. Imagine asking a new student to measure their physical distance to every single person in a massive university before deciding who to sit next to at lunch. It's exhausting, and it takes up a lot of computer memory. Now you might be thinking, okay, this is cool for sorting movies, but what does KNN actually do in the real world? Well, it's everywhere. Think about your credit score. When you apply for a bank loan, financial algorithms can use KNN. They plot your financial profile on a graph, and if your closest neighbors are people who always pay their bills on time, you get approved. Or think about healthcare. Doctors can use KNN to help diagnose illnesses. By comparing a new patient's symptoms and test results to thousands of past patients, the AI can say, this patient's data looks remarkably similar to these 5 previous cases, which were all treated successfully with this specific medicine. It is even used by the post office. When you write a zip code on an envelope, optical character recognition systems use a form of KNN to figure out if your messy scribble is a 7 or a 1, just by comparing the pixel shapes to thousands of other handwritten numbers. So let's recap. KNN figures out what the unknown is by looking at the known things around it. It plots the data, measures the distances, checks the K number of closest neighbors, and lets them vote to make a decision. It reminds us that whether you are a complex artificial intelligence or just a person navigating the world, sometimes the best way to understand something new is simply to look at the company it keeps. The future of industry is intelligent. Let's build it together. Thank you for watching.